All right, in this video, we're going to look at transformations in the real imaginary plane. Transformations in the real imaginary plane. So what we're going to do is we're going to take a point in the real imaginary plane. We're going to take a point and we're going to translate it. We're going to rotate it. We're going to dilate it. We're going to do a lot of things with it. So here are the four basic transformations that we are going to take a look at in the real imaginary plane. The first one that we're going to take a look at is called a translation. All right, a translation, that's where we slide from one point to another point. Right, so it's going to go in a straight line from one point to another point, anywhere on that plane. So no matter where it starts or where it ends, it's going to go a straight line between those two. Right, that's a translation. So it's just going to shoot straight line somewhere. Okay. The second one that we're going to take a look at is called a dilation. Right, a dilation. Right, so this will move. I guess all transformations are movements, so to speak, but it will increase or decrease, depending on what we multiply by, the distance to the origin. Okay, so we can move. Okay, so we can move a point closer to the origin or further away from the origin. Right, so it will always stay on that line, but it'll either move closer or further away from the origin. It's actually a really cool transformation. And this one's really super easy. Might be the easiest one of the bunch. So you'll appreciate that. And the next one we're going to take a look at is called a rotation. A rotation. So we can rotate a point about the origin. So we could take a point and rotate it around the origin. That I think is really cool. We'll do that one. And then the last one we're going to look at is reflection. So reflect over the real or imaginary. Okay, reflection, reflect over the real or imaginary axis. This one, I'm going to let you know now, is definitely going to be, how do I call it, extra, yeah, probably extra credit. This one is not super easy to do. It's not super easy to think about, but it's extremely cool whenever you see it. I'm a big fan of reflection. That one's my favorite, although it's really, really tough. So the three that you are definitely going to be tested over are translations, dilations, and rotations. Okay? So without further ado, let's take a look at translation. Okay? So a translation in the real imaginary plane. All right. So let's start with a set of axes here. Okay. In order for a translation to take place, right, we need a point. It doesn't matter what that point is. So let's just pick some random point. So our starting point is the imaginary number 2 plus 3i. So the imaginary number 2 plus 3i, right? This is the real axis. This is the imaginary axis, right? So 2 plus 3i. Okay? Now, if I want to move this in a straight line, I can move it left and right, so it can translate left or right by adding to the real part, right? Because the real part is the x-axis, that's our left and right. So if I just added 3, so 2 plus 3i plus 3 would be 5 plus 3i. So I would just take it 3 units to the right. And I say adding, I really mean add or subtract, because if I added negative 3 to this, it would be a negative 1 plus 3i. So negative 1 plus 3i would be right here, right? So when I add or subtract to the real part, it's going to move it left and right. So if I want to go up or down, I can do that by adding to the imaginary part. Okay. So let's say we want to move this 5 units to the left and 4 units down. Okay. So what I'm going to do is I'm going to take my starting complex number, 2 plus 3i, and then I'm going to go 5 to the left and 4 down. So that means I have to take 5 away from the real part and 4 away from the imaginary part. Right? So that's my starting point. Here's my translation. And my new point, so 2 and negative 5 is going to be negative 3. 3 and negative 4 is going to be a negative 1i. Negative 3 minus I. So I go place negative 3, 1, 2, 3, negative I. So I wanted to go 5 to the left and 4 down. So 1, 2, 3, 4, 5 to the left, and 1, 2, 3, 4 down. 5 to the left and 4 down. So here, this is my starting complex number. Here, this is my translation. And here is my ending complex number. This is where I started, this is where I ended, and that was my translation. Okay, so what we could do is I could ask you, describe the transformation from point A to point B. Describe that translation, and you could say it would be the complex number negative 5 minus 4i. I could ask you, what's the distance between these two? What's the distance between these two? And so the distance between the start and the end is the absolute value of the translation. So I would take, all I'd have to do is take the absolute value of negative 5 minus 4i, and that would tell me the distance between these two. And that should make sense. I could create a right triangle and use Pythagorean's theorem with 5 as a side and 4 as a side to find my c squared, right? So the distance between the starting point and the ending point is the absolute value of the translation. And really, this is all, I mean, there's not a heck of a whole lot more I could do. I could give you two points and say, what's the translation? What is the complex number that translated from this point to this point? I could, I could ask you to move things so many units and so far and ask you what would be the complex number of that. And I could ask you the distance between 2 points. I think that would be fair. Yeah, so those are translations. Those are translations, okay? The next one I want to take a look at are dilations. So a dilation in the real imaginary plane. So dilation, we're just going to multiply by a real number. Multiply by a real number. Okay, So let's do this. Uh, Take a look at that point again. Let's take a look at that starting point. I like 2 plus 3i. That's a nice little point there. 2 plus 3i. Right there. Okay. Now, I want to dilate this, so I'm going to dilate by a factor of 2. Okay? So I'm going to say 2 plus 3i, and I'm going to multiply it by 2, and I'm going to just distribute through, so I get 4 plus 6i. So that equals 4 plus 6i. Now, when I go to plot 4 plus 6i, 1, 2, 4. Oh, good, it's there. That would have been really embarrassing. Here it is. And if you think about it, right, I increased the distance away from the origin by a factor of 2, meaning here's the origin, and I doubled the distance away from the origin. What if I want to cut the distance in half? Well, I can dilate by a factor of 1/2, meaning 1/2 times 2 plus 3i distributed, right? 1/2 times 2 is just 1. 1/2 times 3 is 3/2 I. So the point 1 plus 3/2 I, 1 plus 3/2 I would be right there. And it's all on the same line, right? It's all along that same line. This, whatever this line is right here, all along that same line. So the original point when I multiplied by 2, doubled the distance. When I multiplied by 1/2, cut the distance in half from the origin. So dilation has everything to do with distance from the origin. Okay, let's take a look at rotation. Rotation, we simply multiply by I. I can rotate a point by multiplying it by I. So I'm going to start that. Let's go with that same starting point of 2 plus 3i. So 2 plus 3i multiply by I get 2i plus 3i squared. 3i squared is -1, so I end up with a -3 plus 2i, so -3 plus 2i. And that point, -3 plus 2i is right here. And if we look at that, I have rotated a distance, or excuse me, I've rotated it 90 degrees. Right, so this is multiplying by I rotates 90 degrees counterclockwise. So that's our big takeaway here. For rotations, only one I really want to worry about is this rotate by 90 degrees. So I can rotate by multiplying by I can rotate 90 degrees counterclockwise, 90 degrees, as we saw here. Right? That is a 90-degree rotation. And we could prove that using slope, right? -2 over 3 would be a positive 3 over 2 would be the opposite reciprocal slope for a 90-degree angle, right? So there are ways of proving it and showing it. But yeah, that is indeed, when we multiply by I, any complex number, not just 2 plus 3i, but any complex number anywhere on here, if I multiply by I, will rotate 90 degrees. That I think is extremely fascinating. Okay, and for those of us that are trying to get some sort of extra credit or whatever, I will say this. Here's your extra credit opportunity. take any point, a plus bi, any point. I want to reflect it over the x-axis. If I reflect it over the x-axis, then that means that b then would be negative. So what then c plus di would I have to multiply it by to get a negative bi? So any point times something. All right, so here, extra credit opportunity. What is the value of c plus di in terms of a and b? Okay, so what is the value of c plus di in terms of a and b? That's your extra credit opportunity. This is really, really difficult. I will not give you extra credit if I walk through this with you on Zoom, but I will give you tips or whatever if you want them. All right. That's it. That's my last video for this semester, and I hope you have a wonderful, wonderful, wonderful summer break. Good luck.